One of the important things to look at with data is a thing called measures of spread. And that describes how far data values are spread from the centre or from each other. So if you imagine that you've got your centre of the data. Now that could be the mean or the median. Either side of that, you're going to have data greater than that and data lower than that. So you have measures of spread which tell you, well, how far spread is the data? Is it all close to the mean? Okay, if you're in a class, our grade 10 maths class, you take me out of it, all the ages will be very close to the mean, okay, 1 year either side. But in other data, you've got data that's a long way short of the mean or median and data that's way ahead of the mean or the median. So you can get measures of spread of the data. How spread out is it? One of the most basic measures is called the range. The range is simply the highest score minus the lowest score. Highest score minus lowest score. So in this set of data, our lowest score is 2.1, our highest score is 5.2. So the range would equal 5.2 minus 2.1 equals 3.1. Highest minus lowest. Okay, so here we've got 3 sets of data and we're going to find the range. Now the last set of data is in order. If you look at A, by the way, there's 3 sets of data here. There's A there, there's B here, and there's C here. One's just a line of data, one is arranged into a table, and the third one is arranged into a stem and leaf plot. So let's look at A first of all. Remembering that the range is the highest minus the lowest. So here, the highest score is 8. The lowest score, so there it is there, 8. The lowest score is 2, there. So the range is 8 minus 2 equals 6. For B, things are arranged in groups. In a table. So 3 people got 13, 6 people got 14, and so on. But what we need to focus on here is the lowest score was 13 and the highest score was 19. How many people got those is not relevant. All that's relevant is what the highest score was and the lowest score. So the range here, the highest score was 19, the lowest score was 13, so the range here is also 6. Okay, so if I wrote all that out, I'd have 3 lots of 13, 6 lots of 14. I'd have a big long line of numbers, but the lowest would be 13 and the highest would be 19. Stem and leaf plot. So we talked before about the stem and leaf plot and how it works. So we've got 17, 18, 18, 19, 21, 22, so on, 30, 30, etc. So our highest score here is going to be 37. Okay, the 3 stem and the 7 leaf. So our range equals highest, 37. The lowest is 17, 1, 7, minus 17 equals 20. Okay, so that's how you work out the range for 3 different types of data. Now I'm going to talk about a thing called the interquartile range. And this is going to lead up to a thing called a box plot, which we'll be looking at probably this week or next week. All right, so interquartile range. So this goes back to the median, and this heavily depends on that formula that we talked about, n plus 1 over tooth score. Okay, so it heavily depends on that. N plus 1 over tooth score. Now we know what the median is, the middle score, and it's with that formula. But we've also got a thing called the lower quartile and the upper quartile. Here we've got the minimum, which is 0, and the not 0, it might be 0, for example, and then we've got a maximum. Okay, it could be 50, 100, 80, whatever. Okay, let's take that 0 off. So we're going to have some values here. The maximum value, whatever it is, 100% of people will be below that. Okay, because that's the highest person. The minimum person, everybody, 100% of people will be above that. But we've got other landmarks as well. Okay, the median, sometimes known as the 50th percentile, okay, means that 50% of people are below the median, 50% are above. The lower quartile, sometimes known as the 25th percentile, means that 25% of people are below that, 75% of people are above it. And the one up here, the 75th percentile, or the upper quartile, 75% of people are below it, 25% of people are above it. So how do we find these quartiles? We'll look at that in a minute. But there's a thing called the interquartile range, and it's the upper quartile minus the lower quartile. Okay? And this is pretty important because in some data you get some really, really low values and really, really high values. So it starts to tell you what the middle 75% are. Okay? It's getting rid of the bottom 25%. Sorry, the middle 50% are, beg your pardon. You get rid of the bottom 25% and the top 25%. How much, what's the range for this middle 50%? Interquartile range. So it's not affected by really, really low data or really, really high data. And it's sometimes a better indication of spread than the range because you get an unbelievably low one or an unbelievably high one, and it makes it look like the data is really spread out. Okay, but it's not. This one will tell you where the middle part of the data is, most of the data in the middle there. All right. So now we have to calculate the interquartile range. First thing we do with these questions is to put the data in order. So I'm now going to order the data. So we've got 1. We've got 2. We've got 2 lots of 3. We've got a 5 and 2 6s. We've got a 7 and 8. Always pays to check that I've got the same number of data after I've ordered it. So 4, I've got 9 bits of data there and 9 bits of data there. So I haven't missed any. Sometimes it pays to tick them off as you do them. That also helps as well. All right. So the first thing I'm going to do, to work out the interquartile range, okay, I need to work out 3 things. The median, the lower quartile, and the upper quartile. All right, so to work out the median, I use my little formula, n plus 1 over tooth score. It might be obvious from this one. I might not need the formula. I'm going to use it anyway. There are 9 pieces of data, so it's the 9 plus 1 over tooth score. 9 plus 1 is 10, divided by 2, it's the 5th score. 1, 2, 3, 4, 5th score. So the median, I'll put it maybe here, the median is 5. 5 equals the median. It's the middle score. Now, the lower quartile, and I'll write this down, the lower quartile is the median of the lower half. So let's circle with a red pen here, or put a box around, the lower half. There it is there, okay? It's the median of the lower half. There are 4 things in the lower half. Okay, so if I apply my formula again, and it's almost, I'm pretending that this is now my data that I'm focusing on, all right? Don't worry about the rest of it. I'm working out the median, the lower half. So I've got 4 bits of data. So I'm after the 4 plus 1 over 2 score. 5 divided by 2 is the 2.5 score. Now what that means is I'm looking at for halfway between the second and third score. Okay, so there's the second score and there's the third score, and halfway between them, halfway between 2 and 3, is 2.5. So my lower quartile is 2.5. It's the median, the midpoint, the middle point of the lower half. Now the upper quartile is the median of the upper half. Median of the upper half. I'll mark this in green with a box. Okay, here's the upper half. There. All right. Now, because there's 4 things again, I don't have to keep doing the formula. If there's 4 things, I'm after the 2.5 score, halfway between the second and third. So remember, I'm just forgetting about all this other stuff. I'm just focusing on this top half. So there's the second score. There's the third score. So halfway between them, there, halfway between 6 and 7 is 6.5. So my upper quartile is 6.5. Median was the middle score, and because there's an odd number of things, it was an exact score. Then I divide into bottom half and top half. I find the middle of the bottom half, the middle of the top half, and I can use my formula to help me out if it's not obvious. So the interquartile range, IQR, equals upper quartile. Actually, I might just write the formula out first before we actually do it. So it's the upper quartile minus the lower quartile equals 6.5 upper quartile minus lower quartile was 2.5 equals 4. That's the interquartile range. That was the original question. I had to find my values here, median, lower quartile, upper quartile. Then I subtract the 2 quartiles from each other. Here's another question. I might not have time to do both of these, so we might just look at the first one first. We'll see how we go for time. I'll go a bit quicker this time. So in 3A, you have to order the data. So 14, 15. Oops, I forgot about 11. So 11 there. 14, 15. We've got a 16. Also got 2 18s. We've got 3 19s. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 again. 4, 5, 6, 7, 8, 9, 10. I've missed one. Let's have a look what I've missed. Right on the end, 20. So I've got 10 pieces of data. All right. First of all, I find the median. N plus 1 over 2 score. N is 10, 11 over 2 score. Okay, that's 5.5 score. So 5.5 is halfway between the 5th and the 6th. Change pen colour. 1, 2, 3, 4, 5. There's the 5th. And there's the 6th. They're both 18. Okay, when they're both 18, the median will be 18. Okay, we have to split the difference there, but if they're both 18, the median's 18. Now I draw a line down the middle there. Oops. So I'll just do that again. I'll draw a line down the middle there, dividing top and bottom. top half and bottom half. So now I've got 5 things in the bottom half. All right, 5 things in the bottom half. My formula again, n plus 1 over 2, 5 plus 1 over 2. That 6 over 2 is the third score. So I'm after the third score here in the lower half, and it's 15. So my lower quartile, LQ for short, equals 15. I've got 5 in my upper half here. So my middle score is this third one, which is 19. Upper quartile equals 19. Interquartile range, IQR for short, equals upper quartile, 19, minus lower quartile, 15, equals 4. All right. Let's have a bit of a look here at the next question. Let's capture that for a second. Let's look at this one. Okay, so this time we're in a stem and leaf plot. So it's 87, 88, 89, actually, beg your pardon. The key here tells me, it's important. Let's get my pen going again. The key here tells me that 9/8 is 9.8, right? Not 98. So I should always read the key. Good lesson for me there. So this is going to be 8.7, 8.8, 8.8, 8.9, etc., 10.0, 10.1, etc. So let's see how many pieces of data we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. There's 20 pieces of data. Okay, so my median, n plus 1 over 2, 21 over 2, 20 plus 1. So I'm after the 10.5 score for my median. Halfway between the 10th and the 11th score. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the 10th score is 9.7. The 11th score is 9.7, so halfway between them is 9.7. Lower quartile. Okay, so I'm going to put a dividing line in there to divide my upper and lower half. My lower half and upper half will have the same number of things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've got 10 in my lower half. N plus 1 over 2. 10 plus 1 over 2. 5.5 score. Halfway between the 5th and the 6th. Change pen colour. 1, 2, 3, 4, 5. So the 5th one is 9.0. The 6th one is 9.2. Halfway between those two will be 9.1. Now, because the upper half also has 10, once again, it's the 5.5 score, same thing. Okay, 1, 2, 3, 4, 5. Okay, so the 5th score there is 9.9. The 6th score is 10.0. Right, what's halfway between them? That's a tough one. If you're not sure, add them together, 19.9, and divide by 2. Okay, and you should get 9.95. Okay, so 9.95. So the upper quartile, it's a tough one, that one, 9.95. Just repeating there, it was the 5.5 score halfway between the 5th and the 6th, 9.95. So interquartile range is 9.95 9.95 minus 9.10 equals 0.85. And there we go. All right, hope that helps. It's a long presentation, but I had to cover a few bases there. Good luck.